So we're going to be looking at network security, and as analysts, what are the key things you need to be looking for in order to identify and to pin down an attacks or a threat in your organization that you're going to be working with. So as you all know, networking is the backbone of IT in general. Without networking, there won't be IT, right? Networking is the foundation to which every IT. Now, I know that IT also is a buzzword where many people has a lot of misconception, but I won't be explaining all of those. But basically, in this context, on any IT, I'm talking about the externalities. You know, it's similar to a building, right? The foundation is not usually seen, but the foundation is very core. So the foundation of IT is networking. And of course, the externality that people see, the fine structure and all of those things, we can relate that to now to cybersecurity. You can say data science, software engineering, other fields in IT generally. But networking is very central and the core and the backbone of information technology in general. So we are going to be looking at some of the how to conduct analysis of network. Now, again, the same mode of operandi, I'm going to be starting with you guys from manual analysis, right? Because it's very important. And the reason for which I'm doing the manual analysis is because, again, I think I emphasized so much on that yesterday. And it's something you also can easily deploy on you can easily, maybe as you are going through the recording of the video, you can also be doing on your PC. You don't have to wait till you join an organization before you start replicating what you are learning, right? So it's something you can easily replicate. You can open your Windows, and we are going to be using native tools, Windows native tools, to do some of this analysis. Augustine, your hand is up.
Yeah, sorry, I was going to ask before the session starts, so I just decided to ask now. You just mentioned it about the recording. I thought we were meant to get that off yesterday after the session. I don't know. From my end, I didn't get any. I didn't get the link to the recording. Did you hear me? Hello?
Hello, sir. Timothy, if you are speaking, you are on mute.
Did anybody hear me?
Yes, I heard you, Augustine.
Yes, we can hear you.
I heard you.
Okay, so I was looking to the recording we were meant to get yesterday.
I think you should check the WhatsApp group. He sent the link to the WhatsApp group this morning, not up to 30 minutes ago. So check it out.
Yeah, the link has been sent to the WhatsApp.
I can hear you.
And we can only watch it online and not download.
Yeah, I know. So I'm not on the WhatsApp group.
Augustine, can you hear me?
Yes, I can hear you, sir.
Yes, so I heard you. I had to mute myself because I needed to pick up the call. So, yeah, on the link will be sent on the last day.
Okay.
The link will be sent on the last day, and alternatively, while you wait for that last day to come, and I believe all of you should have joined the WhatsApp group, because I also shared the link to yesterday's session. I shared it this morning to that group. So if you are not on that WhatsApp group, I'm going to copy it again and paste it, the link to join the WhatsApp group now. I will paste it inside on Teams chats, so you can pick it up from there and join the group.
Okay, thank you, sir.
Yeah.
Yeah, thank you.
So give me a few seconds to quickly do that. So if you check the group now, we see the link. All right. So going back to what I was saying, we have, yeah, as you all know, what we learned yesterday actually was the tip of the iceberg, right? It wasn't the whole thing that phishing analysis entails. The same thing also. So for this particular domain, but let me quickly go through what's it called now, the objective, but we are not going to cover everything, right? So the goal of this domain is to introduce you to network fundamentals, security principle. You're also going to be learning how to manually explore packets, flows, and security controls. You develop skill in performing live pickups or packet captures using various tools such as TCP DOM, Wireshark. Basically, you are also going to be learning how to investigate packets and perform network analysis on the packets. We configure and manage IDS and IPS. So, like I said, we are not going to be delving into all of those things. You learn how to configure IDS, which is not. But for this, today, when I get to the part of hands-on, I will give you a scenario or a backstory to that before I delve into the hands-on, so that I can make a bit of sense to some of you also that are new to the field. So you may be wondering that what's going on here. So when I get to that hands-on part, I will explain further. So let's quickly start. We are going to be looking at, before we get to network security, we need to understand what network is, right? We need to understand what network is. So network basically, we are not, again, I'm not starting from scratch. This will just give you the related, if you, I believe that some of you will understand OSI model, which is the, the template that is used to build network communication and for any devices that is used in information technology. We have OSI model and it has 7 layers, right? So following that structure now, so the layer that pertains to us, we are going to be looking at layer 3, which is the network layer, and layer 4, which is transport layer of the OSI model. Basically, what layer 3 does, again, the protocol that we are going to be focusing on there is IP, which is called Internet Protocol. So this is used for IP addressing. Now, again, I have a variety of people on the call. I'll be trying as much as possible to break this down by using concept that you all are familiar with. So IP addressing, for every devices to connect to the internet, they have to have an IP address, right? So basically, IP address is used for identification and also for network routing in the world of networking. And it's similar to your house, where you are currently staying now. You are staying in the streets, and in that street, it is not only your house that is on that street. You have multiple houses on that street. So each house is going to be numbered. So that number that is given to each house is like an IP address, right? So yeah, that number that is given to each house is like an IP address. And I also want you to think the purpose, the reason for which your house is numbered. Maybe when you order something online and you need that dispatch rider to deliver to you, of course, you are going to be giving your house number for the delivery of the package. It's the same thing also. When you are browsing the internet, when you are going to facebook.com has an IP address. But again, you are not typing the IP address. There's something called DNS that is doing the heavy duty for you. Yours is just to know the domain, facebook.com. But again, it has an IP address. Now, that is the purpose of IP addressing. I will still come back to that analogy. And it's in terms of binary now, it is 32-bit binary number. In other words, the language of computer is zeros and one, or binary, right? Computer doesn't understand English. The only language it understands is binary. So the IP address, if you are to convert it to binary, I believe all of you have gone through basic mathematics in school. You know how you can convert digit to binary. If you are to convert any IP address to binary, you are going to get 32-bit length. 32-bit length in binary, which is zeros and one basically. And it also has a purpose, but I won't dive into that. But what you just need to know about IP address is that it is used for IP address. It is used for addressing and identification and for locating resources on the internet. And the nature is that it is 32-bit binary in number. I will show you sample shortly. And again, it's used for routing. Routing simply means locating resources. So when you go to facebook.com, for example, there is something that will be done at the back end, right? A lot of routing will be made at the back end before your traffic will then reach facebook.com. So basically what is being used in that line is called IP is being used to locate resource, and that is basically what IP or routing means basically. So we then have TCP, right? TCP, which functions at layer 4 of the OSI model. So TCP stands for Transmission Control Protocol. And layer 4 of the OSI model from the word transport. It is used to transport communication, right? So under this protocol, we have, again, the major protocol that we have under the OSI layer 4 of the OSI model is TCP and UDP. We have more than that, but the commonly used protocol is TCP and UDP. So TCP is connection oriented. In other words, is reliable. So for example, this is similar to every one of us. Please, can you mute your mic? Who is coughing, please? Mute your mic. Thank you. Every one of us, and what is it called? Now, this is similar to when you call someone or your friend calls you, right? So I'll be asking you a question now. What is the first thing you usually do? If I were to call you on phone now, what is the first thing you usually say? Anyone?
Hello, who is on the line? Something like that.
Yeah, hello. That is the part I want to hear. We tend to usually say hello. Now, your friend that you are calling, or your friend that is calling you, the reason for which you are calling the person is not to just say hello, right? But you need to say hello first. And when you say hello, if your friend didn't respond, of course, you will not communicate further. You will have to wait until he acknowledges by saying hello. Now, that is basically TCP in action, right? So TCP is used to establish communication, right? And it is connection oriented. So when you say hello, and immediately your friend responds with hello, that means you have come to term that your friend is available to then receive the main reason for which you are calling, right? Now, in the world of networking, the way TCP does that is called TCP three-way handshake, where the client will say, the client I want to communicate with the server will send hello. Now, it is not hello in terms of networking. I just want to use that word so that I can have understanding. We send hello to the server. If the server is alive, if it is active, it will respond back with hello. And the client again will then send another hello. And then that means the connection has been established. So the main traffic or the main message will then start. So if it is web application, you are if it is browsing, you are doing on via web browser, that means a web traffic. If you are sending email, that means it's email traffic that will be sent, right? But now let me go back to how TCP three-way handshake works. We are going to see that in the next slide. So this is used for flows and conjunction control. TCP also is used for flow and conjunction control, right? You may be wondering, all over close to 8 billion people on earth today are on the internet, and internet never rests. Every person is sending traffic. There are a lot of traffic going on in the world right now. And you may be wondering, how is the traffic that is meant for your neighbor not coming to your computer? For example, if you go to facebook.com, not only you, Facebook has over 4 billion, right? A lot of people are visiting Facebook or any website rather that is large that you are using at the moment. A lot of people are also using that website at that point in time. Now, the question to ask is, why is the traffic that is meant, when I mean traffic, now a response to a request you have initiated, right? That is meant for another user, not coming to your own computer by mistake. What is doing that is called TCP. That is the flow and conjunction control. TCP is the one that is making sure that a user A that requests a particular endpoint will get the results of that endpoint, and not user. You will not send the result of user A to user B. So it is TCP that is making sure that there is a flow of network, and also it regulates any form of congestion on the network generally. So that is key factor or key functions of TCP. Now the opposite is UDP. And both of these protocol function at layer 4 of the OSI model or transport layer. So UDP stands for user datagram protocol, right? Now, before I even get to that, the commonly used case of TCP is a place where connection is needed. And almost everything you do on the internet today requires connection to be established between the client and the server before the communication starts, right? So in such example or in such environments now, TCP will be used. When you are browsing the internet, TCP is being used. When you are sending file, TCP is being used. When you are browsing your email address, or when you are composing email and send to your friend, TCP is being used. That is the backbone, right? So UDP, on the other hand, is a protocol that is used, as you can see, it's connectionless. So it's the inverse or the opposite of TCP. So it's similar to that example I gave. You call your friend, immediately you call your friend, you didn't even wait for your friend to say hello before you start talking like parrots, right? You know, that is the way UDP works. So in that context, now connection is not needed. You just need to quickly communicate, which means speed is more important than connection. So that is the purpose of UDP, and the lightweight, lower overheads, and speed. It's prioritized speed over reliability, right? So due to a lot of things that TCP has to do, it usually contain a headers and a lot of payload. But UDP is lightweight. In other words, it's very light. It's not as heavy as TCP traffic, and low overhead, and also in a place where speed is very important, you know, that is where you will see UDP. For example, when you are watching video, when you are using Office line, voice over internet protocol, that is UDP that is being used, because in that line is the speed. You want to be seeing the video in real time. You don't want to be seeing a video that has been played 5 minutes before and is now showing currently on your laptop. No, you want to be seeing it the way it is happening in real time. So in such example now, UDP protocol is what is being used. And again, as we are talking right now, UDP is being used in with Microsoft Teams, because you know, you want to be hearing me in real time, right? It's not that what I have said 2 minutes ago is what you are now currently hearing. You know, it's not synchronizing. So you want to be hearing me in real time. So UDP protocol is what is going to be used. So we're going to be going shortly to how TCP3 branch should work. You know, I said the other time, even though I use the analogy of hello, but in the context of networking now, it is that hello has a flag, and the name of the flag is called SYN. Now, this is the client, this is the server. You want to communicate with the server. Let's say this is a Facebook server. You want to go to Facebook, right? You need a PC or your phone. You need a web browser. You type the URL, facebook.com. Immediately you type that URL, you send it to the server. Of course, you, for non-tech savvy person, they will just see the result on their screen. But for you now, as a cybersecurity and security analyst, right, you need to know the inner working, how those things, you know, move, how the packets move from your computer, and how it get to the server, and how the server query, how the client queried the server, and also how the server responded to it, right? So that's why you need to learn this. So the client send a flag called SYN. SYN stands for synchronization. So we have 7 flags basically that will be used in TCP. We have synchronization, but the majorly used one that you will find there, we have SYN ACK, and acknowledgements. SYN ACK, acknowledgement. We still have Christmas flag, we have finish flag, we have urge flag, we have a reset flag, and so on and so forth. But the commonly used one, or commonly seen one, SYN ACK, and acknowledgement. So the client will send the SYN, which is synonymous to hello that you will say when you pick a call. So if the server is available, now a lot of other parameters will be sent with that SYN. So you can see this SCQ stands for sequence number, which is just a random number that will be generated by the client machine, and it will send it along to the server, right? It's part of TCP payload that will be sent to the server. So if the server is active, when I mean active, if the server is available, now, and I wanted to show you about IP the other time, but it slipped my mind. You know, I've talked about IP in a nutshell, not too long. So let's see what IP looks like on your computer. Currently, for you to be joining this call, you have an IP. Otherwise, you won't be able to be on this call. Whether you are using your phone, you are using your laptop, any device you are using at all, there's an IP that is assigned. So we have 2 types of IP. We have private IP and public IP, right? So on your computer currently now, you are going to be using a private IP. A private IP. We still have classes of private IP addresses. We have class A, class B, class C, class D, and class E. right? But the one you are currently using now, that is meant for SME, small, medium enterprise and home user, usually class C, and usually start with 192.168. So if you open your command prompts on Windows, you press Windows key and type CMD, right? Press Windows key and type CMD. It's going to open up this. So to check the IP address on your Windows, you type ipconfig or ipconfig. As you can see here, and press enter. So it's going to show a lot of, you need to know what this is. MAC address. Since we are not talking about MAC address, I won't delve into that. Basically, this is also used for identification. It is used as layer 2 of the OSI model for ARP or address resolution protocol at switch layer, at switch layer. But again, I'm not going to delve into that. Our focus will be this. If I scroll up now, you can see wireless LAN. This is the current Wi-Fi that I'm using now, and this is IPv4 address. You can see the IP 192.168.1.149. If you also check your own, if you are using your own personal network, you are going to see that it's going to start with 192.168. That is the class. That is the number that indicates that this is a class C IP address. Now, each of these is called octet. Of course, 8 bits is known as, 8 bit rather, yeah, is called octet. 8 bit equal octets. So each of these is called octet. This is octet 1, second octet, third octet, fourth octet. Now, this third octet is what is called network IP, network ID. Network ID, right? And this is what is called host ID. Now, this host ID, this last octet will be unique to every computer. As you know, if you have a home Wi-Fi at home, multiple users can connect to it. An IP address is meant to be unique, the same way your house address is meant to be unique. You can't have two houses having the same number. It's impossible. Please mute your mic as you are joining the call. So the same way your house address is meant to be unique, so also who is this person? Well, I think I may have to retrieve the use of the net from you guys now. So yeah, when I get to the part that I want to ask question and you want to respond, you can respond via chats. My screen is frozen. Are you sure it's from my end? So if you can see my screen, can I indicate via the chat, please? If you can see my screen and you can hear me. So Dynamic says you can't see my screen. I'm not asking you to raise up your hand, please. Just use the chat room for now. So if you can see my screen, you can type yes, 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 yes. So if I have close to 20 yes, I will assume that those that can't see my screen, you may have to leave and rejoin the session. Okay, so a lot of you can see my screen. So if you can't see my screen, please log out and join again. Most likely is the network is your network. So thank you. Thank you. So this is what is called host ID, and host simply means a computer. So it's going to be unique to each computer that is connected to this network. So this indicates network ID, basically. Now, altogether, this is what is called private IP address. Now, private IP address is meant to be used internally. It is not recognized on the internet. So when you are going to facebook.com, this IP is not recognized by Facebook. Any site you are, I'm just using Facebook just to make it simple, but any site at all you are visiting that is not inside your network, this IP is not known. So there is an IP that is the public IP now is what will be used to route your network on the public domain. And to check your public IP, you can type what is mine on your web browser, what is my IP address. And this is usually assigned by the ISP or internet service provider. That's why you see that if you don't have data subscription, you won't be able to use the internet, right? You won't be able to use internet. What's going on here? Can you still hear me? Can you still see my screen? Okay. Well, you can see that this is the public IP address. Joseph, your hand is up. Let me allow you to talk. The other person that wanted to say something the other time too. I don't know what. Oh, you drop your hand, Joseph. It's okay. So this is the public IP address. So any site you are going to, right? This is the IP address that will be seen. Now you can see that this is assigned by ISP, and if you check from here, you can see immediately that I'm using MTN. Yes, I'm using MTN. Even though this thing is sensitive, I ought not to reveal it to you, but no problem. I believe that even though if you want to try, some of you that may have a malicious mind, you want to try something malicious with that, I dare here for you guys, right? But I'm just saying that so that you can know what to review and what not to review. This is, you ought not to show this. It's meant to be, even though it's public, it's unique to you. Now, the implication of this, now let me digress a bit. I'm not going to the implication of, to the offensive side of cybersecurity. Now, the implication of this is that if you have 10 users currently connected to your home router, and when I mean 10 users, 10 computers currently using your computer, all of them will be using this one public IP. There's something called NAT, network address translation. Again, I don't want to deep dive into networking because it's not the sole aim of networking, the topic we are dealing with. But what that NAT does is the one that resolves all the communication that is coming from the internet to the private IP. So if those 10 users are connected to the one computer, like I said, all of them will be using this one public IP. So if all of them will be visiting, all the 10 users will be browsing internet randomly. They are not going to be using the same site or visiting the same site. So one, let's say for example, one is going to Facebook, one is watching YouTube video, one is doing something else, you know. So NAT, so as the traffic is being sent out, it will be carried by this public IP, and then public IP will be the one that will locate the external resources, for example, facebook.com. So when the response is coming back, there's something called NAT, or network address translation, which will be the one to assign, okay, user A was the one that requested for facebook.com, and you send the response to user A. User B was the one that request for another site. It will send the response to user B, and so on and so forth. Now, the implication of that, security-wise, is that if an hacker has compromised your Wi-Fi, right? That's why those of you that think that you don't have anything that's how an hacker can implicate you, if they compromise your Wi-Fi and they're already connected to your Wi-Fi and they're already using your internet, that means they will be assigned this IP, this public IP, and they will be doing those malicious activity on your IP. Now, all the malicious activity they are doing, the IP address, which again, this private IP is what their own machine will have. And any external site they are visiting, this is the site. And every site you are visiting on the internet will be logging all this IP. That is why when you go to some site that is censored, for example, it will tell you that you don't have right to come to this. It will even block you. You will not load. The way it's checking is because of this IP. So this IP now is assigned to Afrinic. Now, Afrinic, we have, Afrinic stands for Africa, Africa basically, and the pool of IP are actually assigned to organization in Africa, particularly ISP in Africa, by IANA. They are the one that assign IP. So the ISP now, they then sell this IP address to you guys based on subscription level. That's why when you don't have data, you won't be able to use internet. Now, every site you are visiting, this public IP is being logged. So if the cyber criminal now or malicious actor now is doing malicious thing on your computer with your network, it is the public IP that will be seen, not the private IP. So let's say they were able to detect that the guy was committed fraud and he used your network to carry out the fraud, and the forensic analysis is being deployed and they are conducting research. They were able to discover that this IP, for example, was given to you, Mr. Easy, for example. I don't want to use my name, was given to Mr. Easy. And again, FBI can easily detect that this pool of IP was assigned to Afrini, basically in Africa. And they can query their database and see that it was given to MTN. And they can go to MTN. MTN can, okay, at so point, this IP was given to particular person. And again, MTN has your location. They know your location, where you are. They know your house. They know all those information, even though it's not showing here. Even here, you can see that it's showing wrong information here. I'm currently in Lagos, not Edo, right? So based on those logs, they can pin you down. Of course, you are not the one that carried out the malicious activity, but it was done by somebody that was able to compromise your Wi-Fi network, for example, based on you are using weak password, you are using default credentials, you haven't changed your password, and the guy leveraged on that and was able to gain access to your network and was using your network for malicious activity. You will be the one that will be arrested, even though you don't know anything about it, but you'll be the one. The reason is because your public IP address that was assigned to you by MTN at a certain time was the one that was seen in the analysis that was carried out by, let's say, incident responder, So I'm just saying, I said I wanted to digress, just to emphasize on the importance of this also. That's why I said I ought not to show this, but if you want to try something malicious, I'm here for you, actually. For those of you that may have a malicious intent, but it's okay. So let's go back to where we're coming from now. So TCP/3 handshake, like I was explaining, the SIM flag, right, will be sent with the IP address, to the server on a particular IP address. So the server, if it is active, is going to respond with SYN ACK, as you can see here, SYN ACK. The way TCP will know that it is server that is responding is that it's going to, I said that the client will come up with a random sequence number. So if the server then responds, the server will then add a number to the acknowledgement number. So the sequence number is 100, right? So when the server responds with SYN ACK, which simply means I'm available, that hello, when you say hello and the client say hello, that is what this simply means. And it then add 1 to it. So that is how TCP will know that this communication was coming from the initial server. And then the client will then respond with acknowledge, right? So that is how the TCP three-way connection will be established. And again, that is not the main communication. It just will establish connection between client and the server, and the main communication will then start, right? This is also similar to a pipe-borne water. The purpose of pipe-borne water in a house is not just to put a pipe. The end goal of that pipe is to supply water into the apartment that are in a building. So if it is not serving that purpose, that means that pipe-borne water is useless. So the pipe-borne water will always be connected to a source. That source is the tank that is put on the elevated, elevated, what's it called now? Maybe on a building or on an iron and all of that. So it's going to have a pipe that will supply waters into the rooms, right? So the water that is being supplied from the source, that source now is the server. To the inlets, now we can say those are the clients. That is the communication itself. But the pipe itself is just like a rod that establish connection between the client and the server. So I'm just using an analogy to convey this, because sometimes this tends to convince a lot of people. And if you are doing an interview, regardless of role you are interviewing for, you are being interviewed for in cybersecurity, TCP/3 handshake, they will ask you to explain it. You can't bypass that. You will explain TCP/3 handshake, right? So that is that. So I'll be proceeding now to what I have next. So common ports. Now, IP and port number are very critical in the world of networking, right? So you need to know common ports. So when we're talking about ports, it's not the physical port where you put your USB cable on your physical laptop. No. Ports basically is logical numbers that are assigned to computers. Again, it's assigned by IANA, right? IANA is one of the body that regulates networking and networking protocols, right? So they are assigned by IANA and they are categorized into 3. We have common ports, which is the one that we focus on now. Common ports usually start from 0 to 1025, if I'm correct now. So port 21 is usually used for file transfer protocol, as you can see before you. This is used to transfer file between systems, right? Port 22 is for SSH or secure share. When you have a server, a cloud instances on AWS, and you need to access that cloud. You will not have to travel to, let's say, America. You don't even have the money, for example, right? I'm not underrating you, but I'm just giving you a concept here. So let's say you deploy an instance on AWS. AWS is the cloud service provider. right? They need to give you a way for you to be able to connect to that instance. So you are the protocol that I usually use, or the service that I usually use for that is called SSH. So SSH will give you access to be able to connect wherever you are in the world to that server, wherever it is also in the world, right? Without you having to travel to the physical location. So SSH, often used for secure remote command line interface. You have Telnet for 2325 for SMTP. When you are sending mail, we talked about, well, even though we didn't talk about how email works yesterday, right? I will leave that to a later time. But basically, when you are sending email, when you compose email on your email client or MUA, mail user agent, like your Gmail, Outlook, and you click send, the protocol that is being used to do that at the server side, to route your email or to relay your email from your client to the relay agent, is called SMTP, or Simple Mail Transfer Protocol. It is used for sending emails. We have DNS, domain name system. So DNS is basically like your contact list. You have a phone number and name. So just imagine that every contact you have collected, you have to be memorizing them by numbers. It's impossible for you to memorize. So what you do instead is that you have my number and you save it with my name, Timothy. You have Tosin number, you save it with Tosin's name. So whenever you want to call Tosin, it's not the number you'll be typing. You just type Timothy and the number will come along with it. That is basically what DNS is. So it's like a list book or phone book that contains all the known domain in the world. When we're talking about domain, facebook.com, gtbank.com, access.com, and so on and so forth, that is domain. So for each of these domains, they have an IP address. So DNS has a record. So whenever you are going to access.com, again, computer doesn't understand English. Domain name is not meant for computer. It's basically for human being, to help you to save us from having to memorize IP address, right? So when you are going to facebook.com, DNS will be the one that will check the phone book and see that, facebook.com, for example, belongs to 192.168, for example, 192.168.10.10, and then it will send your traffic and so on and so forth. That is the purpose of DNS. And the port number that is used, that DNS uses, is 53. We have 80 ports for web traffic, which is hypertext transfer protocol, post office protocol, port 3. Now, this is also for email, but this is for client side, right? So when I send email to you now, you get it in your inbox. Immediately you click on view or open to view it. The protocol that is used to you use to retrieve email from the email server and for the client to view is called port 3. As you can see here, post office protocol, and it uses port 1110. We have 135. These are proprietary, what's it called, ports. It belongs to Microsoft. As you can see here, this is Microsoft Interprocess Communication. It is used for remote procedure call, RPC, on Microsoft, and it's used port 135. We have NetBIOS. Again, this is for Windows file and printer sharing. We have Internet Message Access Protocol and IMAP or IMAP. So again, IMAP is also used for retrieving a email from a remote server. Now, the difference between IMAP and POP3, IMAP is what is being used today. Basically, the major difference is that POP3 supports, IMAP supports synchronization. What does that mean, right? In other words, when I send email to you, you can retrieve the email, whether from your phone or from your laptop. You can log in. For me now, I have my email login on my laptop and on my phone. So when somebody sends email to me, I could either view it from my laptop and from my phone, and the email will persist, right? That is the meaning of synchronization. And the email will also persist. It will not delete. But when POP3 is being used, you can only view the email once instead of viewing it multiple times, and you can only view it from one device. And as you all know, that is not the way the modern email works. So the protocol that is being used in the modern email communication at the client side for retrieving email from the remote server is IMAP, or Internet Message Access Protocol. Of course, POP3 is being used in a tightened or secured environment where they want security. But again, focus there is the port number. So we also have LDAP, Lightweight Directory Access Protocol, and it's a centralized directory and authentication service. So again, this is also a Windows-based protocol, and it is used in Active Directory. For those of you that are working in an organization, there's an Active Directory, which is an internal network, and it is used for authentication via Kerberos when you are authenticating via NTLM. So LDAP is the protocol that is being used to authenticate a user that is logging in into Active Directory or related service in an internal organization network. We have 443, HTTPS. That padlock you usually see on your web browser when you are visiting any website, that is 443. It uses port 443 rather, but that is basically what is called HTTPS, Hypertext Transfer Protocol. So HTTP with encrypted communication. So the SDS stand for SSL/TLS, or Secure Socket Layer Transport Layer Security. Basically, the security, the padlock that indicate that the site is secure. So the port number it uses is port 443. We have 445 or SMB, server message block. Again, this is for Windows. It is used for network file and pattern sharing in an internal network in an organization. We have 3389 for RDP, remote desktop protocol. This can be used for graphical interface. So SSH can be used for command line. When you use SSH, you won't be able to have access to click a button to basically graphical user interface. You won't have access to that. But with RDP, for example, when you are using AnyDesk, I don't know how many of you have used AnyDesk before, TeamViewer, or RDP in general, you'll be able to have graphical as you're going to be having access to the graphical user interface, right? So the port number that RDP uses is 3389. Now, again, these port numbers that are listed here are those that are related to commonly seen port number when you are doing analysis. And these are port number or different service that cyber criminals usually use whenever they are breaching or they breached an organization, right? So 3389, attacker usually use that to gain access to RDP into a remote server that they've compromised, maybe as a result of misconfiguration from the customer end or from the organization end. SSH, again, is one of the way. LDAP, again, when they are brute forcing, when they want to dump Kerberos, conduct Kerberos team or, Kerberos attack, right? Yeah, Joseph, let me unmute you. Give me seconds, please. So go ahead, Joseph. You should be able to unmute yourself now.
All right, sir. Thank you real quick. So I wanted to ask if LDAP is a different protocol from LDAPs, because I know they use different protocol numbers. LDAP is 389, and like you said, is for NTLM and all that. So LDAPs is also, do they run the same process?
Yeah. So the S that you see there is basically SSL/TLS, which simply means that it's secure. Now, LDAP is not secure by nature. Lightweight Directory Access Protocol. In other words, there's no encryption inculcated into that protocol. But whenever you see S, even all these things that I mentioned, IMAP, there's IMAPs. So all these basically are weaponized without security integrated. But anyone that you see S simply means SSL/TLS, which simply again shows that it's there's a security to it. So LDAP is not secure, but LDAPs is secure. But of course, it's going to be using different port entirely, right? Yeah. So we have welcome. We have 8080, which can be used again, is hypertext transfer protocol, and this is usually used by developer when they are in a staging environment before they deploy their code into production environments. So internally, when they are trying out some features on their web, on the application they are building, they usually run those applications on port 8080 to access it on the web browser. So it's also used for HTTP, right? So yeah, all right. That is where our theory will stop. Now, to show you hands-on, but before I go to that part, I want to show you, I want to also give an analogy to explain the concept of IP and port number, how they are both used on the internet. As we talk right now, both of them are being used on your computer. They are being used. Now, again, going back to the analogy I was giving with IP, I said the IP address is like your house number, and every house number is meant to be unique, right? So if a visitor is coming to visit you, you can give them the house number, a particular street, and when they get to that street, they look for the house number and they come to that house and meet you. Now, in a modern I don't know how many of you live on island in Lagos. Even though in mainland, there are some residential apartments where you have 4 tenants. I'm not talking about face me and slap you, right? Residential apartment where you have 4 tenants staying or 2 tenants staying in that same house. Basically, 2 of these residents, let me use 2. Now, if apartment where you have 2 residents, there's apartment A and apartment B. Apartment A is occupied by resident A, what's it called now? User A, and apartment B is occupied by user B. So basically speaking, 2 of these users will be using the same IP. In our context now, in this analogy, they will be using the same house number. So if user A orders something online and he wants to have a dispatch rider, if you are following my thought process, I will ask a question, and any person that wants to respond, just use your hand to respond, to signify that we allow you to use your mic, and we can hear from you. So if the user A orders something online, he wants it to get delivered to him via dispatch rider. So what are the things that the user A now will be giving to the dispatch rider? Let's say Jumia, for example. Okay, Samad, okay, you are the first person I'm seeing. So I'm going to be unmuting you now, or allow you to use your mic. So go ahead now, Samad. Sharon, I can see your hand too. So just 2 people, 2 persons, okay, actually. So Samad, go ahead. Okay, Sharon, go ahead. Unmute, Sharon.
Okay, sir. So first off, I will give them my name, my phone number, my house address, and also my apartment address when I know I have there various compound or building in my apartment in the compound.
All right, thank you for being detailed. But what I actually need is just 2 things. Okay, let me take Tosin also. That will be enough now. So Tosin, you can unmute now and go ahead, Tosin.
Okay, so I'll give them my street address and my house number.
Is that all?
Of course, the landmark of where I stay, more or less like my location, my full names, and my phone numbers as well.
All right. So I think, yeah, Sharon actually captured the thing that I needed. You are correct too. Sharon said her name, her phone number, her house number, and the apartment number. So the 2 things that I need from what she said was the house number and the apartment number. So again, house number, I've been using the analogy to be synonymous to IP address. Now the apartment number is like the port number in our context. So that then means that we could have one house hosting, running multiple ports. Now, if you understand that analogy now, basically you could have one machine. Again, one machine is going to be having a single IP address, and that one machine can be used to run multiple services. So for example, on your computer, you can be running FTP service, and it's going to be running using which port? Let me go back to that slide. So what port number is FTP? You can use your chat to respond, but let me just go ahead now since you're already seeing it. So that machine can be running FTP protocol, which is going to be offering file transfer, and it's going to be running that on port 21, right? SSH port 22, and all of them will be on. You can be running them on a single machine. They will all be sharing the same IP address, and that is the way internet works. Otherwise, just imagine that in your organization. Okay, let me use, for many of you that are not yet working in a corporate setting, you may not be able to comprehend that. But let me use something that is that we're familiar with. So Facebook, for example, now, do you think that Facebook, as you are uploading on their Facebook chat, what's it called, application, there is a space where you can upload picture to your profile picture, where you can upload status and all of those things. Now, do you think that they have a separate server? Of course, Facebook is big. Actually, they have resources to do that. But in a normal context, all of those operations, SSH server can be run from a single computer. FTP service rather can also be run from the same computer, right? HTTP service can be run from the same computer. So what is going to identify those traffic is the port number. But all of them will be having the same IP address. You are going to see shortly. right? So I needed to say that so that the next stage, because we're about to start the analysis. So when we start the analysis, I think it's going to make more sense. So now, why I want to start the analysis now, I'll be powering up my machine. I'm going to be powering on my machine now. To do that, when I'm in my machine, the labs I'll be using, I'm going to be, give me some seconds. Let me quickly change my mouse. Okay, so I think yesterday, I've talked about VirtualBoss, the virtualization software that can enable me or enable you all to have multiple instances of operating system running on your computer. So the two machine I'll be using, again, I'll be using Ubuntu, which is going to be the security analyst machine, and our target in this contest will be this Windows server, right? So I will start the two machines now. Of course, both of them are on the same local network. Now, to help us with this analysis, I'm going to be putting on first of all an ethical hacker's hat. I don't want to say bad hacker, right? I'm going to be putting on an ethical hacker's hat. So in this mode now, we are currently in ethical class. I want you to assume that we're in ethical class because what I'm about to go into, I will take my time to explain it so that I can have understanding, because you cannot stop an attack you don't understand. As a security analyst, you must have the mindset of an attacker, right? That's when you can be able to stop them. And that's why I want to, now in this mode now, we are currently in, white hat mode or ethical hacking mode. So now what I want to do, we are going to be creating a malware, right? We simulate an attacker, and attacker, of course, when they want to compromise, they will have a malware. We talked about malware yesterday. They will send the malware to the victim, and when the victim click on for example, or open the malware that was sent by the attacker, of course, that is when the malicious activity will start, and the victim will get compromised. And of course, as security analyst, your job is to now start looking for artifacts that could pinpoint the attacks. What kind of attack? What is the goal behind the attack? What is the objective of the attacker? Who was behind the attacks and those information? So currently now we are in ethical hacking mode. So to show you process, I'll be using a framework called Cyber Keychain. I don't just want to dive into it. Like I said, I'll be taking a bit of time to show you how one of the methodology of framework that hackers use. Again, this is used by both ethical hacker and black hat hacker. So this is developed by Lockheed Martin. Now, the process of hacking, the first stage is called reconnaissance. So reconnaissance is where the hackers go all out gathering information about their victim. They need to know their victim, the target rather, not victim at this point yet. They need to gather information about the target. They gather information such as email addresses, conference information, both from OSINT or open space, anywhere they gather the information. Now, let's say they've gathered information, based on the information they've gathered and based on the vulnerability they've identified in the information. So to streamline it to what I will be doing, I'm going to be using those specific information. And now in this case, let's say I've gone out. When I mean gone out, I've done my research, go to done open source intelligence, leverage on paid feed intel and all of that, and I've been able to gain information about my target that they are using Windows operating system. In the environment, they use Windows operating system and they are not using Linux. The attack I want to conduct now, I'm targeting a server, right? Of course, in a corporate organization, most of the operating system that is used by users, it's Windows. But for servers, it's usually Linux. But based on my own information that I've gathered, I noticed that this my target are running they have a Windows server Windows server running. So based on that information, and the next thing, I've also noticed that, okay, let me just stick with that one. Based on the information, the next thing is to weaponize. So when we're talking about weaponization, this is where attackers are coming up, developing malware to exploit the vulnerability they discover in the information gathering stage. So basically, they are weaponizing malware. They could either be using a third-party malware, or if they have the knowledge of software development, they can write the malicious script themselves and all of that. But for me, in this context, we are going to be using a framework called Metasploitable 2 to really generate the malware and all of that. I won't be writing the script. Don't worry. I won't go. I'm not a developer myself, all right? Even though I have a bit knowledge of scripting and all of that, but I'll be leveraging on a framework called Metasploit. Now, after they've weaponized the malware, the next stage is to think of how to deliver the malware to the victim or to the target, right? Which is called delivery, as you can see here. So the delivery stage, this is where they will be using phishing. They can use drive-by download. They can use Trojan. They can use USB by dropping USB, malicious USB or rubber ducky in a parking lot in an organization and write some juicy name on it. For example, payroll information and all of that. Hoping that somebody, one employee of the organization, will pick it up and put it inside network, inside the PC that is connected to organization network. So that is when they will be thinking. Now, let's assume that it has been delivered. The malware has been delivered into the target machine. Now, the malware will then exploit, which is called exploitation. So the malware will exploit the vulnerability that was discovered by the attacker when he was conducting his reconnaissance, which is called exploitation, as you can see. So at this stage now, the attacker is already inside the organization network. Everything that we do from, of course, the malware will do some installation. So attacker will also stage some advanced tools that they will be using. For example, they can stage mimicards to dump, what's it called, an hash of NTLM on Windows. They can stage maybe bloodhound to further gather internal information of the, to further do enumeration of internal organization to understand how they are structured, what are the vulnerabilities on the Active Directory, and so on and so forth. So basically, they are going to be installing additional tools, right? They can install Hydra for brute force attack, and so on and so forth. So once that is being done, there will be a command and control server. So basically, command and control server is just like a server where the attacker will be sending all those malicious commands from. And as he sent, you are going to be seeing it soon. As he's sending it, you're going to be getting a live response from the victim machine. And from there, the last one is action on objectives. So action on objective, this is where the stage where the attacker will be achieving their objective. The objective could be to deploy ransomware. It could be to, steal or exfiltrate sensitive information from the organization and then resell it for malicious purpose and all of that. Now, I needed to walk you through this stage. We are still, again, I need to walk you through this stage so that I can understand where we're going to. So I will go back now to my to my Ubuntu. So my Ubuntu, I'll be using it as the C2 for the command and control server. And this server, which is going to be my target, this Windows server, this is a Windows server, right? So I'm going to log in now, control delete in some seconds. Shift delete. Control delete. Yeah. So I'll be logging in. And on this, there's Active Directory running on this, but I'm not going to get into all of that. Right? My goal here is to just, because we are still going back to the analysis part. That is the focus of this training. But I just needed to show you how an attacker can create a malware and use that to exploit a vulnerability. So the malware we are creating now is going to be a Trojan, actually. We talked about the nature of Trojan yesterday. It's going to impersonate a malicious tool. It's a software that is malicious. While you get what you are asking for, at the same time, it's also going to be doing some malicious activity on the system. So, all right. So let me start now. So the first thing that we need here, or that I need here, is to create the malware. I haven't gathered my information or I haven't conducted reconnaissance. I've identified my target is using Windows and I want to target their server on Windows. So I'll be generating a payload, a malware now to exploit that vulnerability. So the malware I want to generate now is a Trojan, right? So to do that, I'll be using, I already installed this tool. It's not installed by default on Ubuntu, but it's installed by default on Kali. But I already installed it on Ubuntu. Make directory, I'll call directory malware. So what I'm doing right now, I created a directory called malware on my desktop, right? So I will change directory to malware. So inside this malware folder now, I'll be running, I will generate the malware now. So to do that, I'll be using MSF Venom, which is part of Metasploit framework, right? So I'll be selecting a payload, and the payload will be determined by the architecture of my target. In this case, is Windows. So I'll be using a payload that is specific to Windows environment, Windows interpreter, reverse TCP, right? So I'll be selecting a file now. The file extension I want to generate is executable. As you all know, on Windows, it's exe, right? F stand for file extension, and selecting exe for executable, or PE executable for Windows. So the next thing, I'll be specifying the listing hosts. Now, this LO stand for the IP address, which is the command and control server where the malware will communicate back to. And to get that, I'll be using Ubuntu as my listening host. So I quickly need the IP address. Copy it from here. Copy and paste it here. I also need L ports. Now we talked about ports and IP, right? So the port number I'll be using, I'll just use 444. And the rest is the port cybercriminal I usually use. And I'm being deliberate here because when we start analysis now, those are the things you are going to be looking for, right? So L port 444 and dash O, the output file, I will call it not malware, not malware.exe. Not malware.exe. So let me come over it again. I'm using MSF Venom to generate the malware, and I'm selecting the right payload based on the information I've gathered. My target is using Windows. If it were to be Linux, I will put Linux here, but because it's a Windows environment, that's why I selected Windows. And I'm specifying the type of file. It's going to be executable, right? And I'm specifying the command and control IP, which is again my Ubuntu environment, and I specify port number. So if I press enter now, it will take some few seconds and will generate the malware for me. And the next thing that will come to my mind is, how will I then deliver this malware to my victim? Of course, since this is not a real hacking whatever, attacker will come up with different means. But for my own context here, I quickly spawn a Python script, a Python server, right? And then I will go over to my victim or the target machine and download the malware. Basically, that's what I'll be doing. So let me walk you through. So you can see, this is the malware that has been generated. If I type ls now to see, not malware.exe, and if I check the string, file not malware. You can see that it's PE32 executable, and it's for Windows. So the malware has been created. Again, following the cyber keychain, the next stage is to, how can I deliver this malware, right? So to do that in my own context, I'll be running Python script, Python server -m, Python 3 -m -m http.server, right? So I've started the server. What this simply means is that I turn this computer to a server. So what I then need is this IP address, right? IP address, and you can see that the port number that the server is running on is port 8000. So I will go back now to the victim machine, and I will quickly download the malware. Let me close all this. So let me see if I can paste. Yeah, I can paste. Okay, 8,000, right? So I've specified the IP address and the port number that the server is listening on. So you can see the not malware.exe. So I'm going to click on it to download. So not malware.exe. It's now yet downloaded. Let me click on it. It's downloading now. Yeah. So you usually see this, particularly when you are downloading file. This Windows, what's it called now? Windscreen that is going to tell you, do you want to keep this? It just tell you that this can harm your file because it's an executable that you are side loading from an internet, right? So I'll just click on keep. So let me delete this one. I think I downloaded it twice. So I'll keep this one. So if I go to my download folder now, the file should be there. See, this is not malware.txt. So before, of course, before the attacker will have sent the malware, they would have started a listener, right? A listener. So I'm going to be starting that now, starting that on this tab. So to start the listener, what I just need to do is type MSF console -q for quiet. I don't want to see all the banner and all of those design on my screen. So this is what I'll be using now to set up the listener to receive the connection whenever the victim click or open that malware. So you can see, so if I now to set up the payload now, again, I'm not going to explain all those things, but I'll just try as much as possible to explain the command I'm using. So use, from the word use means use. So I want to select exploits, all right? Use exploit multi-handler. So this is an exploit that can be used to handle multiple environments, whether it's operating macOS or Linux or Windows. You can see exploit multi-handler. So I'll press enter and I will set payload. So the payload basically that I'll be setting is the payload that I used when I was configuring the malware. So I'll just copy it here. Copy all this, copy and go back. Set payload, Ctrl+Shift+V to paste. If I type options, you can see the payload has been set to this. Now it's still remaining L host. In other words, the IP address of that we configure when configuring the malware, as you can see. So I'll copy this also, copy and go back. So I'll paste set L host, paste the IP address. So if I type options again, you can see that it has been filled for me, and by default, it already filled 4444. So what's now left for me now is to run it. And to run it, I just type run and press enter. So I've started the listener on the attacker's machine. The listener is already running now. Of course, the victim he has been deceived into downloading this and is about to now open it. But for me, I'll be opening it from command prompt, CMD, right click and run as administrator. So I will navigate to that part. So I'm currently in administrator user. So if I type dir, list the directory. So I will change the directory to download, cd downloads. Right, dir again. You can see the not malware. To just run it, I'll just type it out and press enter. Right, nothing is showing, nothing. But let's go back to the attacker's machine. We should have received a reverse connection. Can you see? Meterpreter session 1 open. Currently now we've hacked into that server. So you can see the IP address of the listener and the port number, and you can see the IP address of the victim 161 and the port number. This is what is called ephemeral port, right? Ephemeral port that is being used to communicate with this listener. So to show you sample, I can type sysinfo. If you check sysinfo, you can see the computer green. You can see the OS architecture, Windows Server 2022. You know, basically the attacker has gained access, he has compromised. If I migrate to share, so you can see now that is the same thing you are seeing from C user administrator Windows download. If I go to that, it's the same thing. If I type dir, it's the same content you will see here. And if the attacker also do the same thing from his own side, it's the same content. So we've hacked into the machine. Now, this is where we stop the pen test mode. We will now switch back now to analysis. Now that the attacker has compromised and you are being asked to do a live analysis of an endpoint, how do you start? That is the focus of this, all these thing process we've gone through now. So I will go back now to that Windows machine. The first thing for is to retrieve the infected. Of course, I'm not going to be explaining IR or incident response. But for as many of you that know, the IR, there's a process in it. The first thing for is to contain. So containment will include containing the infected endpoint, infected machine. In other words, you want to separate it from other networks, and from there, you then start doing analysis in order to identify patterns of malware and then eradicate, right? So following that process now, we have been conducted, or you have been hired as a security analyst, or you are called upon to come and because you are working for an organization that has been hacked and want to do analysis on this server, how do you go about it? That is where we're going to start our analysis. But before I delve into that, I saw some hands. If you want to ask questions, please identify, just use your digital hand. I saw some hand the other time while I was doing, just 2 persons. I will only take 2. But it will do me well and do me good if it's just 1 person that is that I can see here. So Athanasius, go ahead, Athanasius. Joseph, you can unmute your mic rather, and go ahead.
Okay, sir. Please, good morning once again.
Good morning.
So, sir, first of all, I wanted to find out whether my first question is is the Ubuntu and the server on the same network?
Yeah.
And secondly, okay. So, and secondly is my second question is, I wanted to find out when you created the executable malware. I was thinking after you being able to download it from the server side, you are going to create a listener using the NC rather, instead of using
I understand. Yeah. So, and that is another way by which you can create a listener. But I was just saving myself all the audios and all of that by using MSF console. It's still the same thing, but we are going to get to that part in the process of analysis. I will still create another malware using that what's it called, a PowerShell. But again, it's a good question you ask. So we get to that part now that I will create a listener with NC or netcards. And then we are going to know the difference.
Okay,
again, that's another way by which attacker can set up listener to obtain reverse shell from a compromised computer. Yeah. Thank you for that question or contribution.
Sir,
Anastasios.
My last question, please.
Okay.
So I wanted to find out on the server side, was the antivirus activated? Like, was it?
No, it wasn't. Of course, this will be flagged. Yeah, this malware now, if I were to hash the malware, right, and check on virus total, which is one of the things you are going to be doing. Of course, virus total will quickly detect it based on the payload. It's the payload the payload the MSF Venom used to generate this malware. It's it's been populated in all the AV or the antivirus solution out there. So basically, the anti-malware or antivirus is turned off on that server. Of course, we are in security analyst class, so I don't want to be delving into all the how to bypass this thing and all of that. That is not the focus of this training.
Thank you, sir.
Yeah. All right. So, Michael, you can unmute now and go ahead, Michael.
Yeah. Hello. Can you hear me?
Yeah, I can hear you. Go ahead, please.
Oh, just 2 questions I needed to. The first one was, you confirmed we are on the same IP for this effect because we are using the local IP address. So if you're on a different IP, it's the same IP is going to access. So it's a different IP.
Now,
a different network, rather.
Yeah, so of course it's not going to be. Can you mute now? Can you mute? Ask your second question. I think your background is somehow because I'm hearing my voice.
Oh, sorry, it's the TV. Let me just lower it.
So ask your second question so that I can take the 2 along. All right, I believe.
No, just go on. This is fine.
Yeah, please mute yourself. Yeah, please. I'm still, my voice is re-echoing from my own end here, and I don't know why. I think it's from your end. So thank you. So the question you asked, now if this were to be done, you are going to be using cloud. If attacker were to carry this out, they are going to be setting up the listener. They will have generated the malware using a public IP. The IP I used to be generating the malware, like I said, is a private IP. And the private IP is not known on the internet. So if attacker wants to generate this now, they will use a public IP that is easily accessible on the internet, regardless of the network the victim is using or the target is using. The reverse share will be obtained if it's a public IP that is used here. right? So basically that is the difference. So yeah, I believe there's no other question. Let's quickly move now to the PT machine and start
Sorry,
the
one more thing.
analysis.
Sorry, if you don't mind, one more.
All right, go ahead.
Okay, second was the Windows. There was no specification. If the malware were generated, does it actually work on literally a specified Windows? No, you use Windows Server for this. Does it work on every other Windows? There has to be a specific version of what you are generating it for.
It worked from. Now mute your mic, please. Mute your mic. Thank you. So it's going to work for Windows 7 upward. For Windows 11, any version of Windows is going to work for. You can see that this is server. This is server 2022, right? Okay. So having gone through that now, let's go back to analysis. Now to start the analysis, the first thing you want to do is to have visibility into the network traffic that is currently ongoing in that segregated computer or segregated endpoint. What do I mean by segregated? A computer that will identify that is infected and want to do analysis. Maybe the user has reported to you that the service the computer is slow, or based on the attacks that the attacker has carried out, maybe they deploy ransomware and all of that, but you want to now carry analysis out. Again, you want to start from network analysis. And we are going to be using practically native tools. What do I mean by native tools? These are tools that are integrated. They are pre-compiled with Windows. They are all on Windows version, whether Windows endpoint or Windows whether Windows computer or desktop or Windows server, they are all there. And the first one, which I'm going to be using, is network status, right? So I'll be opening terminal now. Now we are functioning as we are about to start the analysis. So I'm running as administrator again, and then type net stats. Sorry, my spelling is not correct. Let me clear the screen. Net stats. But before I press enter, even though I know the command to use, but let me give you a page. So this is how to query the app or manual for this net start. So if I press enter now, right? So we are going to be using -A, which is going to display all connection and listening ports. But because this is a server, so if you are doing this on your computer, the output of my own may be much more. In fact, it will be much more larger than yours because I'm doing this on a server. If I were to be doing this on a desktop or user desktop, what you are going to see may be different, right? When we run this command shortly or very soon. So B is going to display the executable involved. So we are going to be using -AB, and O will display the owning process ID, right? And N will display the address and ports, which is very important. We want to see the IP address and the port number. You know, like I said, IP address and port number are widely used. In fact, they are used together for communication across the internet, right? So I will clear my screen now, and I will run the command again. This time around, I will just put -AN. I could do it this way, ANOB or ANO, or I could do it -N, -O, -B. For this is not wise. I would rather just put everything together and no. So either of the two options will work. Now, so again, it's going to show a lot of stuff because I'm on a server, right? So I will scroll up while it's displaying it. Let me scroll up. So if you check the column, of course, the malware we created in this context, we created it, and it will be easier to identify. But let's say no malware that we haven't identified before. So what we are going to be looking for basically here is what is called anomalies. We are going to be looking for something that deviates from the baseline. Now, before this thing occur, organizations should have a baseline. So baseline simply means a good known state of a computer. So when something abnormal is occurred, they can easily identify, right? So I believe before this, I'm just saying that to put it in a proper context, when you are doing this in real world, organization will have established, well, not all organization, but a secure organization will have a baseline that they are following. And when malicious activity occurs or anomaly occurs, they will be able to quickly identify anomalies by comparing the anomalies to the baseline they've established before the attacks occur. So you can see that it's still going, but for me, I'll just stop it. But in real world, you want to leave it to display everything, right? To display everything, but I will stop it by pressing Ctrl C. Wow, it's not even responding to my prompts. Ctrl C. Yeah, so I've stopped it. So I will scroll up now so that we can start the review. So if you check, we have active connections. And we have proto column, we have local address column, we have foreign address column, state and PID. PID stands for process ID, right? So protocol stands for protocol. You can see it's TCP. Majorly, what you are going to see here is TCP, TCP UDP, right? You can see the local address. You can see the state. Now, the focus is the local address. Of course, all of them are focus. All of them are what you need to take notes. And again, when you are doing this analysis, you'll be taking notes of the artifacts. Right? Again, artifact means IOC. So you can see the IP address, the state. Now, listing means this computer is currently running as a server, is waiting for connection. In other words, it's if any person should connect to this is a loopback IP now on port 88. That means it's going to receive connection. But what we are looking for is any state that is established, that is in established mode rather. Right, that is in established mode. So you can see that this is in established mode, this is in established mode, and this is in established mode. Now, if you check the related informations, so this is on 192.168.161. That is the IP address of this server, and this is 389. I think we talked about that in our this is LDAP basically, because this is server LDAP is running on this server. There's Active Directory on it, like I said the other time, but that's not our focus. But these are the things you are going to be looking for. Right? And you can see the related process. This is lsas.exe. Again, these are legitimate process on Windows. We may get to that. I may give you some intro into that, but I'm not sure that I'll be able to cover that. But talking about process, those are the things you also need to learn to know legitimate process in Windows. So basically, all these are processes, dns.exe, dns.exe, which are also a binary. As you can see, exe stands for executable. Right, but if you check this particular one, TCP, and it's connected to a remote server, as you can see here on port 4444. What are you noticing? This is the IP address of the Ubuntu, and this is the port number that the Ubuntu or the command and control server is listing on, as you can see, and you can see that it's in established mode, which means that there's connection going on between them. And if you check the name of the image part or the binary, can you see? Not malware.exe. Not malware.exe. Of course, what you want to do here again, you want to take note of this guy, the IP address and the port and the name of the executable and majorly the process ID. Now, I haven't identified the process, the not malware.exe, and we've identified the related process ID. You want to take note of this. Now that we've identified this, based on this process ID, we will then start doing analysis in relation to process, ID. Of course, there are other tools you can use to also conduct. We have TCP view, which is a GUI, but I'm not going to be delving into that. I just want to stick with native tool. In other words, tools that are easily available with Windows, right? Without using external tools and all of that, and all of this manual process analysis. Now, I haven't gotten the process ID, of this malware. So what we are now going to be doing is to conduct process analysis. So process analysis, basically process in Windows means executable binaries that are running. And there's something called parent to child process relationship. I think I will stop here. Let me quickly give you, if I have it open already, if I have it open. Okay, yeah, I have it open. Let me just show you. So I believe you've seen something like this Task Manager on Windows, and it's called processes. So processes basically are running instances of program and applications. It could be the running instances of programs and applications. It's going to be showing you the amount of CPU they are using, the amount of memory. Yeah, of course, we also have some what's it called now? Windows processes. So we have system or Windows processes. These are when you see system.exe, sms.exe, csrs.exe, lsa.exe, all those are Windows core function processes. they are owned by Windows and they are being used by Windows to perform certain tasks on your computer. Otherwise, some of the functionality on Windows will not work, right? But of course, attacker can inject malicious binary into a legitimate process, right? They can do that, but I'm not going to be delving into all of that. We also have user application processes. So this basically are processes that will be running when you start any application. For example, Chrome. Any application you start, like Notepad, there will be a process, right? Any application at all. That's why you could see that this not malware. When I started it the other time by using command line, there's a process that has been assigned or process ID. And this process ID can be used to search across all the networking security that is deployed in a SOC environment. It can be used to search on the scene. You can use it to search the EDR or the endpoint detection response. You can use it to search on the IDS IPS tools that have been configured to see different information or malicious activity that is related to that process, right? So now what I want to explain is parent to child. Now, parent process. So when you start a process, which is going to be a parent process, it can have a child process. So for example now, right, you know this, I deliberately opened that malware, not malware with terminal. I deliberately opened it with terminal. Now, we are going to hunt down, based on the process analysis that we are going to move to now, we are going to hunt down what is the parent process. How can we gain a mental picture? Now, you know, it's because I ran this malware myself, but in a recent, let's say you are doing this every time, you will not know how the attacker opened the malware. Sorry, how the victim rather opened the malware. So the way you can know that as analysis is through the process ID. You can use the process ID to correlate the related parent process ID. So this process, actually, we are going to be using this process ID now to identify how the victim opened the malware on the computer. Of course, I use CMD. You should know the answer, but how can we get that now, right, manually? So I will copy this guy now, Control C, and we are going to be using another tool called WMIC. Again, this is a Windows native tool. I've forgotten the full name now. If I search for you, WMIC, I think Windows Management Instrumentalizations, whatever. WMIC, yeah. You can see a Windows Management Instrumentation. Yeah, Windows Management Instrumentation. That's the meaning of WMIC. And that is the tool we are going to be using for what's it called now? For the process analysis. But before that, we want to also check. We're also going to be using task list. So task list is the command line of task manager. I believe all of you know task manager. You can use task manager to see running process, but again, I want to stick with command line. So command line of task manager is task list. So I'll be using that first of all to see the related processes. So to check that task list, again, first that question mark to give me the help page. Right. So if I scroll up now, the first one I'll be using is dash V. So which is going to display all the tasks or processes that are currently running. Right. It's going to display it in a jumbo format, but let me do that first so that I can see. And you then learn how to streamline the information we are looking for. Task, my spelling, task list. So you can see, again, it's going to show all of the tasks and the projects that are running, but it doesn't make sense right now, right? But if I scroll down, we see we have image name. So image name is just the image. We have process ID, session name, and so on and so forth. Like I said, it's not shown in a way that you want, but we are going to, I'll be supplying some arguments now. So we are going to be using task list dash M also. Now dash M, if you use dash M is going to show the DLL or dynamic link library, which is basically API, Windows API, that each of the processes are currently using to perform different tasks, right? So let me clear my screen again and type task list dash M, enter. So you can see it's going to output a lot. Let me press Ctrl C. So for this example, this is a process. You can see all the DLL or dynamic link library. Again, these are Windows API that can be used to perform that a process can use for they are just like packages. If you have understanding of programming, there's a packages that you can integrate into the software you are building instead of building everything from scratch, right? So this svc host.exe is using all these DLL. that you are seeing here to run at the moment. And again, attacker can inject a malicious DLL into a legitimate process in order to bypass AV or antivirus. But again, I'm not going to be delving into all of those, but I'm just explaining at the overview level. So we are going to progress now. Now we are going to now be finding, I copied the process ID of that not malware.exe. So if I paste it here, let me see, yeah, 3944. That is the process ID of not malware.exe. So based on this now, we are now going to be using task list. I'm going to streamline it to where we are going to now. Task list -m and -fi. -fi means find, right? And I will put equal what is it called now? Quotes and PID. So I want to search based on PID or process ID. So I will type equal or EQ PID equal this number, right? Basically, I believe that is well understood. So I'm finding, so it's going to, -m is going to show the related DLL, and I want to streamline it to not malware.exe, and I'm searching that based on the process ID number, and if I press enter now, it should output, you can see that the image name is not malware.exe, and the process ID is 3944, and the modules or the DLL. Now, the reason for which we are going this far, we are inspecting what sort of DLL is associated with this malware. Now, this DLL that you are seeing here, they are legitimate, but like I said, attacker can inject malicious DLL here. So you want to do deep inspection, but all of these DLL you are seeing, they are non-malicious. Of course, how do you get to know? You can copy, search on Google. So this is ntdll.dll. If you search on Google, you're going to see what that will do. This is Windows on Windows 64 DLL. This is again Windows on 64 architecture DLL. So all of this basically is legitimate. But again, that is I'm just giving you a thought process of analyzing a malware on an endpoint. I haven't used the network, I haven't used Netstat rather to see the network activity that are currently going on in the affected endpoint. You then get the process ID, and you want to now do process analysis. So having gotten the process analysis, you can use task list to zone in order to get the related DLL. Of course, in real time or in real life, you want to manually verify all these DLL by searching on Google. And again, you want to also make sure that attacker can spoof. Instead of O, they can put capital 0. And you will think that is the normal wow, right? So those are the things you are going to be looking for also. So when you're inspecting this in real time, actually, you're going to be opening your eyes. Again, instead of O, attacker can put 0. That is typo scouting in order to deceive you to think that is the wow 64. Rather, it's a fake one. So I haven't gotten this now. So what we are now going to be doing, we want to see the parent process of this not malware.exe. So now we are now want to do mapping or process ID. Based on this process ID, rather, I want to see related process. How did the attacker or how did the victim open this not malware.exe on the endpoints? So we can identify that via the parent process ID, right? So to do that, we are going to be using WMIC. I've said that the other time. WMIC. Now, if I pass question mark to get the manual, this has a lot of documentation, and this can be used basically to query anything on Windows. But the one we are going to be focusing on, you can see it's actually to press next. Like I said, we are going to be focusing on process for process management. Again, if I bring it up again, instead of / I will type process, and to also see the help page for process. So these are other arguments that you can use. So you can see get. Again, I'm deliberately going this route just to give you a understanding of what I'll be typing shortly. So if I also put get to see what command can I use, or what parameter can I also add to that. So if I press enter now, you can see these are different information we can query. You can query command line, which again I will show you shortly how important this is. We can query OS name, you can query name, you can query a lot. You can see parent process ID. That is what I want to query with that tool. So you can query parent process ID and so on and so forth. So I will just stop it now and go back and quickly type it out. So WMIC process get I want to get process ID, equal the process ID that I've copied of that notmalware.txt. Wow. I think I lost this thing now. So let me quickly get it again. CLS. So net start dash ANOB or AONOB. Let me control C right now to stop. Cancel. I think I've seen it here. This is it. So it has a process ID of 3944. Control C. So I'll paste the process ID here, 3944, right? Sorry, WMIC process. Where, so what I want to do now, I want to revert the order. So where process ID equal to this, right? So what we are doing now, we are getting the process ID, we are searching based on the process ID of the not malware.txt. So I will go to the next line now and type get. So we want to get process name, first of all, the name of the process, process ID itself, even though we know it, and the next one, parent process ID. So WMIC, where process equal to this process ID of not malware.txt, we are getting name or retrieving name, the process ID and parent process ID. So if I press enter now, okay, alias not found. Hold on, I could see your line in this and yet invalid query WMIC process. My spelling correct? Yeah, I made a mistake here. My spelling, I'm sorry. There should be double S. Should be a double S rather. Let me check my spelling again. WMIC process. Yeah, process ID. WMIC process, where process ID equal this, get name, process ID, and parent process ID. Yeah. So, yeah, I didn't structure it well before. So, WMIC, so we are querying process, and we are saying where, right? Where process ID equal 3944. So, we are now retrieving the related information name, which is this. This is what we are seeing here, not malware.txt. And we're also getting the process ID itself, which is 3944, and the parent process ID. Now, this is the parent process ID. So with this parent process ID now, we can pin down how the attacker was able, how the victim rather was able to open the malware. We can gather that information with this parent process ID. So what we then need to do now is to see this parent process ID, what image part does it belong to? Or what is the name of that parent process ID? Before I go into that, I think I saw some people saying the other time. Can you raise it on? Can you raise your hand now so that I can allow you to use your mic? Yeah, Amos. Hold on. Let me allow you now. So go ahead.
Okay,
Unmute.
thank you, sir. Yeah, my question was, what kind of metrics or clues we can look for the baseline? Even suppose that the attacker is an insider and he already know the baseline, or maybe he trick you by modifying maybe the DLL the DLL of the malware that was uploaded, or even its hash, so that it won't look suspicious. So what kind of metrics or clues you can look for to know that this process that's running is malicious or was not intended to be running normally?
Yeah. So what you are going to be doing Of course, you are going to be checking the image name. So if it's an executable that is not normally seen on the network in the organization, like I said, that means it's an anomaly. So for you to identify what is normally seen, there's a baseline that the organization is using. So when something is happening that is not, in alignment with the baseline, you guys can easily be detected. And of course, you want to check the port number. Attacker usually use, random port number like 4444. That's one of the metrics you can use to determine if that is malicious or not. And of course, the IP address, the remote IP address. You want to copy it, use some file reputation such as VirusTotal, right, to check the reputation of the IP. Has it been associated to be hosting malware in the past? So those are the things you can start doing. But for me, you can see that I'm not doing that here, right? I'm not doing that here because I want to stick with the manual analysis for this aspect. I don't want to use tool. But again, as you are doing the manual analysis, you are going to still be leveraging on web service such as VirusTotal, Cisco Talos to check the reputation of that particular artifact to gather whether it's actually legitimate or it's malicious, right? So that is the thought process actually. So,
okay, thank you.
Yeah,
Thank you, sir.
you're welcome. So I haven't gotten the parent process ID of this notmalware.exe. So we then want to see, I'm going to be using WMIC again to query the name of this parent process ID. So if I type that again, WMIC process, for this time around, I want to get name. I want to get name, parent process ID, and process ID itself, process ID, and I will be piping this into find, right? So this is a pipe. It can be used to run two commands together. So I'll be finding this parent process ID. So I'll copy it, pipe, and paste this here. I think I should just type it 1244 and enter. So let me come over it again. So I haven't gotten the parent process ID of the notmalware.exe. We then want to see the image name of this parent process ID. And to do that, use WMIC process, get name, parent process ID itself, and we are now piping that into a command called find. So find, we look for 1244. Once it discovers it, of course, it's going to be this parent process ID. And then if we show the name, that is our focus. We want to see the name of the software that was used to open this malware, right? We see the name, we will see the parent process ID, we also see the process ID. So if I press enter now, if my spelling is correct, everything should be perfect. Now, you can see that we have notmalware.exe, we have onhost.exe, we also have cmd.exe. Now, the notmalware.exe, now based on the way I arrange it here, so the name, that's what we are seeing under here, followed by parent process ID is the parent process ID, and this is the process ID. So the notmalware.exe, which is our focus, you can see that the parent process ID of notmalware.exe is 1244, which is what we've identified before. And the process ID of notmalware.exe itself is 3944, right? So if you also check, if you analyze this also, onhost.exe, this is a Windows service or Windows process. It has a process ID of, parent process ID of 1244. In other words, this onhost.exe also was opened via CMD, which was started by Windows. Those are the application or program that starts at startup, but that is not our focus. Our focus is this notmalware. So let me just skip this part. So if you go to cmd.exe now, you can see that the parent process ID of this CMD is 3808, and the process ID of this CMD.exe is 1244, and is what notmalware.exe tallies with. So from here, we can conclude that this notmalware.exe was opened with cmd.exe. That's the analysis, and I'm going to also replay it quickly now. So what I can do, I will stop the malware, right? Let me go to the attacker's machine and we will redo it, but I will start it, the malware, in another way. Instead of using CMD, I'm going to be using File Explorer. Let me stop the attack first. Exit. exit again. So my listener is already configured. Let me options, right? So I will just type run to start the listener again while I go back to the victim machine. This time around, I'm going to be using File Explorer and double click. This will usually open .exe file. So I will double click on it. So let me check. Yeah, it started listening and not malware.exe. Click on one. So let's go back to, let's observe it from here. So you can see that I already have it. I've obtained shell, capital shell. If I type shell now to go to stable shell, so let me quickly repeat what I just did. Of course, immediately as we started the malware, the process ID will have changed. That's what you need to know, right? And so the first thing I need to get is the process ID again. So to get it, I will just repeat this command. Let's start -anob. So Control C. In real life, you want to allow this to run completely, but because I've gotten what I want, that's why I'm pressing Control C. So if you check now, the process ID is 1258. So I will copy it and go back, and I will quickly repeat this. Instead of 3944, I will put it here. 1528. So here we now have a parent process ID of 3808. So I'll copy this again and bring up the last two commands. So instead of 1244, I will paste that 38, enter. So if you check here now, again, we have a lot, even though you are seeing CMD here, but the malware was actually open with explorer.exe. This is what they call Explorer or File Explorer. Or if you check, based on the information we have before us, so the not malware.exe has a parent process ID of 3808 and the process ID of 1528, right? The explorer.exe has a parent process ID of 992, but process ID of 3808, and that is what tallies with this. You can see it here, it tallies with this. So from here, we can conclude that the attacks was open, the malware was open rather via this, right? So now, the next command that is also important when doing the analysis, in case where the cyber criminal run a command line, we can also use this WMIC to get the command line that was used with this not malware.exe. But in this content, you are not going to see, but let me show you WMIC again, process where process ID equal, I think the process ID now is 3808, yeah, 3808. So I will type get name, get, this guy the same thing, but I just want to change the parameter this time around, get name, and the command line. So if you check, you can see that I point to explorer.exe. And again, the process ID I use is the explorer.exe. It should be the process ID of not malware, which is 1528. So I'll copy that again. 1528. So you can see. So from here now, we are seeing where the malware is actually being resided. Now, one of the things you also need to know, the way attacker works, they usually install malware in a location where you cannot easily identify it, maybe in temp folder, maybe in public folder. But the way to get where the malware is actually residing on the victim machine, we can use this process to get it. So you can see that it gave me the full paths. Administrator, download not malware.exe, and from here, you can go to that full path, rather, and uninstall the malware. But in this context, it's not showing related command line, but I will show you sample now. So to do that, I will stop. I don't have to stop it actually. I will be using netcat, but I'll be using an online site. It's called RefShell or reverse shell generator. A RefShell to really generate a PowerShell script. RefShell, right? So The IP address, this will be the IP address of my listener. I'll be setting up the listener here. So let me open a new tab, if config. Let me look at the IP address, if config. I will be copying this now, copy, go back, I'll paste it here. So I'll be using a random port 4545, for example, 4545, right? And the shell I want to generate rather, I will be using a bash. Where is it again? Now let me scroll down. Yeah, I'll be using PowerShell 3 base 64 because I want the payload to be encrypted or to be, as you can see here, to be encoded. As you can see, it's been encoded. So I will scroll down and I can make this. I will just leave it as shell the way it is. And basically, I've generated the PowerShell script, right? I've generated a script. I'll copy it. So this, of course, I will run it from the victim or the target machine. But for me to run it, I will need a PowerShell. PowerShell is another built-in tool that cyber criminals usually leverage to compromise or to gain a reverse shell. So I will open PowerShell now. PowerShell. Run it with administrator. Okay, before I paste it, codes, I need to set up the listener. And to set up the listener, we'll be using netcat nc nc. What's the IP address again now? 192.168.1.133. I hope I'm correct. Let me cross check, because if the IP address is not correct, I won't get the shell, reverse shell rather, 133. 133, right? And the port number that I use for 545. And I press enter. Oh, dash key to specify what am I doing? Netcards. I made a mistake here. Sorry. LBP. So L stand for listing, B stand for verbose, and P stand for port number. So I'm listing on this IP address. Again, L stand for listing, B stand for verbose, and port number is 454. I'm still getting error. Let me cross check. Let me clear my screen again. Getting error here. So netcards dash L for listing. So let me troubleshoot one after the other. .168 .1.133 dash P 44545. Let me present that. Yeah, it's still throwing error. Let me see. Set destination ports. Yeah, I've specified that. So who's seeing the mistake I'm making? If you are seeing the mistakes, those of you that are familiar and conversant with netcards, you can send in what's it called now? Yeah, N. Yes, I'm missing N. Thank you. So NLVP. Thank you. Yeah. NC dash LNVP. 192.168.1.133 and 4545.
I guess the port number should have colon and not space between the IP address and the port number.
Hello,
All right.
sir.
Yeah, go ahead.
So it's supposed to be the NC tag, the LVP. You shouldn't put the IP address. It's supposed to be only the port number.
Thank you. Thank you for that.
Only the port.
So the port number of this IP is already specified. We take it by default. So it's going to be listening on all. Thank you. Who was that? Who was that? It's when you want to connect to you use the port number, the IP address. So it's going to be listening on all the interface, the ETH. If I open the terminal now, IP config, it's going to be listening on all this interface, right? But of course, loopback will not be connected because I have to connect from 1270. So the one that will connect is this, right? Thank you for that. So having the listener started, I will go now to oh no, I need to restart the server. Let me quickly restart it. So if you have any question, wow, it's 12:03. If you have any question why this is coming up, let me see your hand so that I can use the opportunity to take them before I proceed from there. Any question? Yeah, go ahead. Go ahead. Athanasius.
Okay, sir. So, sir, I wanted to find out if it could be possible to find out like who the target, like who executed the malware. Because let's take we being a SOC analyst and sitting down and you just got this notification, you got an alert. We want to find out like which staff like clicked on that malware.
So here's
Is
a
it
good
possible?
question. Of course, it's possible. Very, very possible. In fact, on Windows, even though I didn't intend to show you guys, but that's a question is now going toward EDR. But I only was focusing on network security today, but I will show you since you have the question, you've asked the question. I'm going to show you guys shortly, but let me complete this aspect first before I go to that part. So I'll go and copy the script again. Copy. Just paste it. So if everything function well, immediately I press enter, I should obtain a reverse shell on the attacker's machine. It's still pasting the command. Right, enter. So you can see it's not showing anything. But if I go back now, connection received on green. That is the name of the computer. So if I type shell to gain a stable shell, I think it should work. Yeah. So again, I've gone back to the stable shell. You can see PS, which means the PowerShell script. If I type dir again, I've obtained a reverse shell again. But let's go back now and do the analysis again and see the command line, which was the reason for which I was going through this again. I'm going to open command prompt as administrator. We are going to be using firstly get the network. Let's start. We need to always start from network to get the process ID, the image name, and other information, particularly the process ID associated with that. Now it's not going to be not malware.exe again. So or again, I'll just stop it because I'm seeing a lot of output now. Or I really go to established and start sifting it from there. What I'll be looking for is PowerShell, PowerShell.exe. Let's ask. Yeah, can see here PowerShell.exe, and this is the port number. But what I need is the process ID so that you can get the command line So I copy this, and in the WMIC, I'll be using WMIC now. A process where process ID equal to that process ID, and I'll be getting the name, get name, process ID itself, the parents. I think we've done this. I'm just repeating it. Let me just go straight to the points. Let me get the command line. I don't have to get command line. Voila. Can you see? When I use it on not my web, it only show the part. But here, because the script was run on the PowerShell directly, you can see that we are retrieving the same command line. And from there, of course, I haven't gotten this. This base 64 is something we can decode, right? So what I'm going to do now, we copy the base 64 entirely, right? Copy, and then go back to my analysis. So we could either use what's it called? I don't need this again. Let me exit. Control D, clear my screen. So I can decode it by echo. I will type echo. I type in echo on my command line, echo, and paste that script into these two codes and pipe it into base 64, base 64, base 64 dash D to decode. So that, because right now I can't make sense of this thing that we are seeing. So from here, we can be able to know what sort of information is hidden behind this data. Of course, this is a TCP client. If you know about PowerShell script, TCP client, and you can see that this is the remote IP that the attacker is to be connected to. The what's it called? The connection is to be made back to or to reverse to, and you can see the port number, right? Basically, we've been able to get that via the manual analysis. Okay. So to answer your question, the question that you asked the other time, so if I go to, so we are going to be, I will just show you event viewer for in real time, and the efficient way of doing what you ask is via the ADR and SIM that has been deployed in the organization. So as those tools are capturing and also detecting malicious activity, it's also going to be having the attribute of users, right? That where is my, okay, it's going to be also going to be having the attribute of users that perform the task, maybe that open a malware, right? So if I search for event viewer and run it as admin, so what I just searched for, again, there's for every event, even before that, let me clearly explain it. For every event, so the major event that is being logged on Windows endpoints, we have application security setup system. So application has to do with application logs. Security are the security events that you are going to be monitoring for, and the system. So anything that has to do with security will be logged under security. So if I click here now, so for every event, there is a number that Microsoft has attached. So if I just search now, file creation, because when the victim download the malware, it's actually creating a file. A file will be written to the disk of that victim. Can you see file creation event ID? That's what I want to search for. So you can see event ID of 11. File creation event ID on event viewer. Let me specify. Again, it's 11. So file create operational log when a file is created or overwritten. This event is used for monitoring auto start location like startup folder. Again, we didn't get to that part. Also, auto start is usually used by attacker to achieve persistence. You know, when I finished, or in real, when I finished all the thing I was doing, I press Ctrl C to stop. But in real world, attacker want to deploy persistence, and the way they do that, they will inject malicious binary into a registry file or auto start location where whenever the victim start up the computer, the malware also run as startup. But let me search based on that event ID of 11 and see if we are going to get anything out of that. So you can see these are the events, right? So what I'm going to do now, quickly filter. I click for filter current log. and specify the 11. If there's anything like that, and click OK. Yeah, OK. So no task, no event. As you can see, it returns 0. It returns 0. But hold on. Let me see. Let me go back to Twitter current log and remove this. Just let it show everything. So what I can also search for here is Twitter current log. Let me apply Twitter and first set it. So process creation. So this has to do with process. I think from here, we should be able to get that. Of course, event viewer is limited, but we also have 6 more that can be added. So I just first set here, as you can see, process creation. So we talked about process in a nutshell the other time. When a file is created and the file started, it's going to have a process ID, right? So from this process creation also, we should be able to detect who ran or who opened a particular, file that we are hunting for. So let me put this into full screen because I don't like when my screen is just so small. So if you check now, let me drag this a bit up. We have a process, a new process has been created. And you can see the creator subject. This is a system and the so this is for LSAS actually. This is one the process we're looking for. To get that process, of course, it's not the right way to start. We need to first of all know the file before we can then use the file process to start hunting for process creation. Because as you can see now, it's giving LSAT. All these are legitimate process on Windows. You can see the instruction and all of that. But basically, the way that can be achieved is through Sysmon. Sysmon also is a third party tool that can be deployed here that will give you additional data that will help us identify who opened the file, from where, from which location. It also gives us the TCP connection, right, of such. So yeah, but TCP event viewer can be used to view the quest to view the events that was logged. So what I will just do now, let me show you sample, right? So what I'm going to do, I will go back. Let me set up the listener. No. Control C. This is not responding again. Okay, this is Metapreter. Thoughts and I'm going to start it. Let me run that. Where is my PowerShell? Let me go to that PowerShell. Nice. See. Yeah, PowerShell. So I will run it again and press enter. I just want to gain the shell. So one of the activity that I'll be doing here, which I usually do, is also to clear tracks, to clear logs, and what's it called now? Event viewer can be used to clear log. So if I go to with utility now, I usually have a challenge with spelling that guy. So I usually use Google. So with util, is it util? Web, you can see with T. There's usually T that I omit. So if I press enter and I just will have, so this enables you to retrieve information about event logs and publisher. Basically, this is the command line of event viewer that I just showed you now. So I will copy this first and go back now. So I want to clear tracks of every action. So for example, attacker, when they have finished conducting their attacks, they want to clear logs. And the logs are what you actually need to be able to identify who was behind the attacks. Can you guys still hear me? Okay, I believe you should still be hearing me. I believe. So what I can type now is with T. But before I do that, let me show you the head page first from here. So if I paste it, if I copy it, let me write it out. With T with T. I think I'm getting, yeah, I got it this time around. So with T /question mark will get you the head page. It's already showing it. So this can be used to clear logs via command line. It's actually event viewer, but it's a command line. So what I'm going to be using, I want to clear the security log. And to do that, I'll be typing CL, right? And the name of the log, which is security. As I said the other time, security log is what this security, any event that pertains to security, this is where it will be stored, saved. So attacker usually clear this log whenever they are done with their activity. So let's simulate that. And we are going to use event viewer to also see that. So what I will do, I will type with T yeah, -CL and security. So CL means clear, and I want to clear the security log. If I press enter, now this action that I perform, a log, an event ID of 1101 should be generated, which means a log has been cleared. And that is very important when you see that in a SOC environment, maybe on a scene or on the EDR, that a log event ID of 1101 is very, very important for you to quickly respond to. So let's view that. I will go back now to this, to my event viewer. Let me expand and let me try and refresh. The security log should have been cleared. See how it here. So let me search for that event ID of 1101. I don't know why it's not clearing it. Oh, it's because this search is still there. So I need to clear it up now and click on OK. Let me refresh. Still there. Let me just search Peter current log 1101 and click on OK. So event processing. So let's just give it a so I think it's still the task that I performed, the attacker send is still in operation. But see, this command should clear the security log. You can see that I didn't throw any error. That means it works. But maybe it's taking a time from here to process. Let me go back and refresh. Let me delete the it's not giving me what I want. Let me run it again. Well, maybe it's because I use PowerShell, that PowerShell script, which was to be done not malware, it will work actually. But you get, I believe you get the idea of what I was trying to do here. So if you also search on Google event ID of 1101, you can see what that is going to do. Event ID of 1101. So audit events have been dropped by the transport. On this page you have what is this? Sorry, I've been typing a wrong event ID. It should be 1102. 1102. So the type of error that occur when the white try event ID of 1102 on events, security events, on Yeah, so you can see this event generates every time Windows security audit log was cleared, right? So if you also read the documentation, you will see how it's tallies with the importance of analysis for the purpose of analysis. So let me just change it. Sorry, I've been typing a wrong wrong event ID 1102. Nothing. Wow, this is surprising. That means the command is not working. It's actually from here. It's from here. If I had used the not malware.exe, it will work certainly. Maybe because of the PowerShell this that I have, the PowerShell may not be able to have the capability to write that instruction on this victim machine. But it's okay. It's not showing still. 1102 is not showing. All right. All right. So yeah. So to wrap it up, I'm going to show you the EDR now. I'll just show you EDR. I'm not sure it's come up. I don't want to show you my organization one, but I have a one that I've deployed on the Machali. The Machali is an EDR, what's it called now? EDR platform, right? Where all these manual activity that I've been doing so far can be automated. As you can see now, like I said, I'm not sure it's going to come up because I tried opening it this morning. Took a lot of time loading, and I think they are still having the same issue. The issue is actually from their end, from the Machali. I think they have okay, let's wait. I think it's loading. So while we are waiting for this, any question? Because I'm not sure it will come up. Because I've tried several this morning. They have a downtime or something like that. So any question? Let me give you guys the ability to unmute now. So if you want to talk via the mic, you can use your mic. Can I unmute? Any question?
Can you hear me?
Yeah, I can hear you. Go ahead, please. Who's
While we are
that?
trying, it's Michael.
Okay, go ahead.
So while we're trying to get the events cleared, so the command we are trying to run supposed to wipe us logs on security event viewer.
Yeah, but that is the event. That is the log that I specify in my command from here. Security.
It's only every log on security or a specific log or the
Every
entire
log,
log.
every log, yeah. This is it. Everything under the security will be cleared.
Well, all right.
So that is what you should have done. But again, maybe because of, let me see if I still have the not malware in my download. Yeah. So let me try for the last time by using this one, ROM. Okay. So going to double click.
Don't bother.
There. Okay, let me just copy it from here. Copy this. Paste.
All right, thank you. So I'll just quickly confirm the store code and account number I've got on here for your wife. Just let me know if I've got that correctly.
Okay.
The parameter is incorrect. So with utility, CL, clearly log, and the log I want to clear is security. Why is it telling the parameter is incorrect? Okay, I've gotten where the issue is. So with the T, CL, security. Oh, with T, the T, CL, security. Yeah, so with T, so it didn't throw any error. So let me check again now. Let me stop this and refresh. Let me go back to event viewer, application, security, and see that the log has been cleared. And a log of 1102 was generated, event ID of 1102, right? So you can see the audit log was cleared. And the user that cleared it is this account, administrator. That was the account that has been compromised by the attacker. You can see that the account name is administrator. It belongs to a domain because it is a server, an active directory, and the tax category is log clear, right? So this is an ID that will be generated, and it's also one of the very vital, important, very vital event ID that is monitored for in the SOC environments. The SOC environments. So yeah, I'm going to be stopping here right now. Any question? Any question? This Limachal is not loading. It's okay. So let me give me some seconds. Let me stop the recording.